We have seen how to create variables in the Matlab command prompt. Now we would see that how to create matrices and vectors as well. For an example, I create a scalar variable a is equal to 5 and b is equal to 6 as we have seen in our previous video. Now if I would want to create a variable c, which is nothing but the multiplication of a into b, I can use this command. Or if I would like to create a value uh, or if I would like to create a variable c where in place of multiplication I just would want to add it, so c is equal to a plus b would be 11. Now for example, if you would like to know what are the variables created in the workspace, you can type whose command. So this will give the name of the variable, the size, and the class. The class is nothing but the data type of the variable and how much byte it is taking in the memory. Now, in order to create matrices, declare a variable and enclose that in the square brackets. So if I say 1, 2, 3, 4, it is going to create a is equal to 1, 2, 3, 4. Similarly, we can do up the scroll bar in the keyboard and 1 column 4. So this will also create a vector A starting from 1 to 4. Now, for an example, if you would like to create a matrices, so create A is equal to 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 9. Press enter and this would create a variable A, matrices of A, 3 cross 3, 3 rows and 3 columns. Similarly, you can create a variable D is equal to a cos of A. So this will create a variable D, which is again the matrices based on the matrix A. Here, the type of the output is decided by the type of input. A is a matrices type of variable over here. So the cosine function would be operated on each and every element of this matrices that would result a variable output, variable D, or of a type of matrices. Now, for an example, if I would like to plot the data, I can write something like E is equal to sine into 2 into pi into t. Once I type this is going to throw an error that undefined function or variable t. Please note down that this has not thrown the error for value pi. Pi is an inbuilt value in Matlab which stands for 3.14, the value of pi, 22 by 7. Now I need to define t is equal to 1 to, for example, in the steps of point 0, 1 to 2. Once I do that, this is going to create an array variable of t starting from 1 in the steps of point 0, 1 to 2. For every variable in Matlab is the array by default, whether it's a scalar or a vector. Matlab is an array-based language. Now, if I would like to plot a graph between E and T, I need to define E, scroll bar up, T, Control C, define T. We have defined T. Now we can type E again over here and now say plot E with T. So this is going to plot a sine wave. Here the x-axis is the variable E and the y-axis is over here as the T. We could actually invert this as well. For example, if I say T and E. So this is going to plot a sine wave basically over here. Now the plot of sine waves inverted between T and E. For example, if you would like to create complex variable in MATLAB, for an example, if I would like to create the variable x and it should be the complex variable, I can write like something 3 plus 4i. So this is going to create a complex variable x with the value 3 plus 4i with the real and imaginary parts. As we have seen that we can create scalar variables and the arrays and the matrices in the MATLAB using the commands as a is equal to 1, 2, 3, 4, 5 for the array, a is equal to 1, 2, 3, put a semicolon and 4, 5, 6 for a matrix. It's not called a matrix unless and until it's a square. So let's say 7, 8, 9 is a square matrices over here. And we could create these matrices by browsing the Matlab help and the Matlab documentation and the Matlab function as well. So there are multiple ways of doing that. Let's click on this function icon over here. Upon clicking, I could see a lot of categories over here. So under the category MATLAB, we'll have the language fundamentals, then the mathematics, the functions which are involved in the mathematics, and then the Fourier analysis, and the data import and export, the analytics, and there are different toolboxes. So based on your application, you could actually browse for these functions. For an example, if I would like to create random numbers, let's click on the random number generation. I would want to use the rand function. Now, upon clicking that, it would show a short description on the right pane side, all the options that are available with the rand function, and a short description at the right side that this MATLAB function returns a single uniformly distributed random number in the interval 0 to 1. Now, let's put this. I say data is equal to rand. I put a close bracket and I say tab. Pressing tab would basically show you an option of all the arguments that you could put inside. Doing this would create a data which the value we could see from the workspace as well over here. The data here is the 6 cross 6 double matrix and it's a random number generator. We can perform matrix operation as well. For example, if I would like to see the size of this data, say size data, it's a 6 cross 6. For example, if I would like to say another matrix P, a transpose of A, this one, yeah. So this will create a transpose. Or for an example, C is equal to matrix multiplication of A into B. It would be a matrix multiplication, perfect matrix multiplication because it's a 3 cross 3, both matrices. So this will give the result for matrix multiplied A into B is equal to C. You could also multiply matrices the element wise also. For an example, D is equal to A dot and then multiplied symbol and then B. This would create a matrix variable D with the result of element wise multiplication between A and B. You could also create inverse of the matrix A by inv INVA. Now, to confirm that the inverse is right exactly or not, what we can do is we can type in A and then multiply this with A. To confirm that we get an identity matrix over here. We can find the inverse of the matrix A also over here. So we can type in A and to confirm that the inverse of this matrix is accurate, we can type in A multiplied with the matrix A. To get the identity matrix makes it confirm that the inverse of the A was correct. Also, we could access the matrix element specifically as, for an example, for the matrix A, we know that the first row is 1, 2, 3, second row is 1, 5, 6, the third row is 2, 3, 4. To access the row 2 and the column third, we can write something like A23. This would give us the value 6, which we can evidently see as over here. Now, for an example, if I say the data, this is the matrices that we created before using the function, random number generator function. Now, if I would like to access the particular values of the rows 1, 2, 3, and for example, all columns. So the simple column over here means all the columns. Right now, upon doing this, this will give me the values of first row to third row and all the column. For example, if I would like to replace this with the value 0, I would basically overwrite the variable data, the matrices variable, the first to third row and all the column with 0. We could also create the surf plots using the MATLAB over here. So for example, that we know that the value of E was sine 2 pi t using the sine wave. we can create a variable WE and then E transpose and then multiply it with E. Now after that we can try surf W. So this would create a surf plot.